Hello guys, I am going to answer a few questions. I think my post kind of went viral, so I thought maybe I need to explain in more details what I'm trying to do and what I'm in the process of doing at the moment. So the reason why I built this is a brand new IDE is because I had the personal need to develop a code editor that could work with local LLMs. The reason why I'm doing this, because first of all, is for privacy reasons. I don't want to share my details with third parties, but at the same time, it's cost, because obviously bills have been skyrocketing, and with the $200 on Cursor, I'm still spending over $1,000 a month in AI API calls. I spent actually nearly 2,000 last month. I do a lot of coding. I code 5 hours a day, and obviously with the free tier, I'm unable to do anything. So, and I have a powerful Mac, and I recently bought a small server, a small machine. You can install a semi-powerful coding model. You're not expecting to hit anything over maybe 10 tokens per second. So it's not going to be amazing, but you can still code. It's still good enough. So the way I've approached this is to have an orchestrator, which is a brain. And this could be something that you can get on either on Llama for free or £10 a month, where you can get a Kimi 2.0 or 2.5, which is clever enough. I think it's Moonshot as another Chinese company, and you can get a really good, I think there is a context window of 256,000 tokens, so it's decent. So you can get an orchestrator to do all the thinking for you. And then the orchestrator can delegate the coder, which is something that sits on your own network. You can have multiple coders. So in my case, I have a Mac. So I have a smaller quen installed on my Mac, and then a larger quen installed on the server. So you can get the coders to actually do the work that the orchestrator sends them. The way it works has been heavily inspired by OpenClaw. So we have a memory system. There is a file system where we save everything we learn from the project. So there are multiple files, and as soon as the orchestrator learns something about the project or decides to install a library, then everything gets saved into memory. So every time we interact with the orchestrator, then it gets clever and clever, because obviously they know more about the project, they know about the library, they know how to run things. So the first time we might have some issues, and then it gets better and better. A bit like OpenClaw. So the second thing is to do with file size. We know that small language models are unable to read large file size. So it's been built from day one to think about file size. So we have small file size. Every time we create a new file to handle something, then we make sure that the file is maximum 2,000 lines long, no more than 2,000. I know something complex can be handled in 2,000 lines, but this is great because you instruct the model to create something that is modular, so you can have multiple coders collaborating on the same modules, because they are able to read it and then send tokens, etc. And then the last one, the one that I think is a game changer, is the heartbeat. So these small models, sometimes they stall, they get confused, they don't know what to do, and then they just stop. So the heartbeat, again, inspired by OpenClaw, is a system that you can set up. Let's say every 30 seconds, you go and check. It's like it wakes up every 30 seconds, or less or more, depends on your configuration. Then you can decide, okay, something is wrong here. I'm not accessing any tools. I'm being on the same instruction for 30 seconds or more, and therefore I need to restart. So in this way, you have a continuous system that never stops until the problem is solved. I didn't find anything like this on the current platforms. So I hope this explains why I'm doing this. Please ask me more questions.